Welcome back. In power plant economics, there is a term which you would come across which is called as economic scheduling. The objective of this lecture is to explain you what this term means. What is this economic scheduling? To understand this economic scheduling, let us say that you are a power system, and this power system has certain combined load. It's a power system which is having a certain combined load. And this load is made by, let us say, two units. One is a coal-based power plant. It is a coal-based power plant, and the other load is made by, let us say, the gas turbine-based power plant. Similarly, you can imagine a third unit of, let us say, a diesel power plant, or there could be two coal-based power plants, two gas turbine power plants, like this. So it is a simple model now. You would say that the load, there are only two units, the coal-based power plant and the gas turbine-based power plant. Now, in order to understand what this scheduling is, we need to look at the question from the perspective of power engineers who are managing the grid. Now, let us say that the load is to be met is 200 megawatt. Hypothetically, let us say the coal is of 100 megawatt, and or let us say the coal is of let me erase this, of 200 megawatt. Sorry. Yeah. The coal is of 200 megawatt, and the gas turbine power plant also happens to have an installed capacity of 200 megawatt. Now, as I told you, the load, let us say, is of 200 megawatt, right? Now, from the perspective of power engineers, he has number of options. One is he would operate the coal-based power plants to the full capacity, that is 200 megawatt. So this is 100% capacity he might operate, and he would not operate the gas turbine at all. Means this would be kept as a standby. This is one option he would do. The second option you might have is, and think of this, that instead of operating coal, he would operate, for example, he would operate a gas turbine power plant, and he won't operate a coal-based power plant. This is also possible. The third option or the third scenario we can imagine is he's not keeping any of the power plant as a standby. So what he's doing is that he's operating both the coal-based power plant as well as gas-based power plant. And let us say that he's operating the coal-based power plant to generate 100 megawatt and the gas turbine-based power plant to generate another 100 megawatts. It means that he's operating the coal-based power plant to 50% load, 50% capacity, and the gas turbine-based power plant also at 50% capacity. This is the third scenario. In this way, you can just go on thinking about the number of possibilities. For example, one possibility could be he's operating coal at 150 megawatt and gas turbine as 50 megawatt. Now, all these possibilities are possible, and technically it is possible to satisfy the load of 200 megawatt. The question is, how do we satisfy the load? How do we satisfy the load so that the variable cost, the fuel cost, is minimum? Means it's not simply a question of technically satisfying the loads. Technically, as we discussed, there are a number of ways of satisfying this load of 200 megawatt. The question, so the way of satisfying this load of 200 megawatt is called scheduling. Means how to operate the power plant. That is called scheduling. Now, how do I operate? How do I schedule the power plant such that the total cost, especially the fuel cost, is kept minimum? That is called as economic scheduling. Now, why is this not a very simple question? That has to be clearly understood. So for that, let me again resort to a few concepts which you already learned in the elementary classes, wherein one concept is efficiency, which we have done when you have studied the vapor power cycles, and the other concept is heat rate. So the efficiency of the power plant, you know, it is nothing but the power output upon the fuel consumption into its calorific value. So let us say that there is a power plant of a certain efficiency. Now this efficiency, for example, if I consider 1 kilowatt power plant, 1 kilowatt power plant upon MF into CV, MF into CV. So this is the efficiency of the power plant. If, or in other words, this is nothing but output. Let me call this output as L, which is the load on the power plant, and this is nothing but the input, which is the I for input. Okay, so efficiency I can express that. Efficiency I can express that L upon I. There is other term which is used in practice, which is called as a heat rate, and that heat rate is nothing but the reciprocal of efficiency, which is input to the load, input to the load. So if you look at some practical numbers, okay, practical figures, or the way these power plants are behaving. So in our case, we had considered two power plants. One is the coal-based power plant, and other is the gas turbine-based power plant. So if you look at the coal-based power plant versus the efficiency, then you would often find that, and let me take different colors so that it clearly differentiates. So this is one color. This is, let us say, coal-based power plant, and the other for this is, let us say, gas turbine power plant. So for looking at this graph, we know that the efficiency is maximum for coal-based power plant. Now, if the load is 100%, if the load is 100%, right, then the efficiency of the coal-based power plant, if you look at it, is more, right? So if I operate the coal-based power plant, if I operate the coal-based power plant at 100% load, 100% load, right, then that is going to give me a higher efficiency, in both the power plants at 100% load. I will get an efficiency of coal from this graph to be greater than efficiency of gas turbine. But now let us consider this point. Let us say this is one point. Okay, this is one point you're having, right, and this is the other point you're having. Okay, so when suppose this coal-based power plant is operating at, let us say, some load. Let us say this is 25%. Okay, 25%. I put it a point small a, and look at this point, which is B. So what is the meaning of this? The meaning is, you see here that the efficiency of the coal-based power plant, which is when it is operating at percentage load A. Let me call this as some 25%. 25%. 25% is less than the efficiency of the gas turbine based power plant. Efficiency of the gas turbine power plant, which is operating at a higher load. Let us say this is 75%. 75%. Okay. So this makes the difference. So if you see that, if you are always operating a power plant, okay, which is having a highest efficiency, and keeping the other power plant which is having a lower efficiency on the standby mode, then you might not get a scheduling which is the maximum efficiency scheduling, or you might not get a solution which is going to give you the optimum fuel cost, optimum or minimum fuel cost. So if this is clearly understood, that the efficiency varies with respect to load, or the heat rate varies with respect to load. For example, the heat rate curve, if I want to plot the heat rate like this, heat rate versus percentage loading, so you find again that if you got this kind of graph of heat rate versus percentage loading, you get something like this, for example. I'll just put a figure in front of you. Let me choose another color. Okay, so this is, let us say, this would be, let us say, typically for coal, the heat rate versus loading, and this is, I'll choose a different color for this. This would be for a gas turbine. Okay, gas turbine. So it means that, and the heat rate of the gas turbine power plant is more. So as we were saying, that efficiency or the heat rate, efficiency of coal is not always greater than efficiency of gas turbine. Not always, not at all loads, Okay. Similarly, the heat rate of GT, it is not always greater than the heat rate of coal. So we need to manipulate. Okay? We need to manipulate the loading such that, or we need to schedule the loading of the coal and the gas turbine or some other power plant such that always the combination of coal and gas turbine would give you the minimum fuel cost. So that is the meaning of the economic scheduling. So it's just understood what is economic scheduling. So in the next few videos, we will be doing some concrete example, one derivation and one example to understand this concept well. So economic scheduling, in short and to summarize, means we need to schedule the operation of two or more power plants such that the fuel cost is minimum. Thank you very much. That's it.